In this section, we will learn about what the Watson Conversation Service is and how the service works, what the service is comprised of, how dialogue flows work, and lastly, we will look at some uses for the service. So the Watson Conversation Service is a tool that understands natural language input that simulates conversation between humans. Basically, it allows developers to create a more human-like interface to their application. With this service, a user can initiate a request to an application simply by asking for something as they would ask another person. This interface can be built using existing messaging services like Slack, Facebook Messenger, or any other text or voice-based services. This service also works great when used with other Watson services. For example, a user can use natural language to query a large body of information or even trigger an IoT device by using Watson Discovery or Watson IoT Platform, respectively. Best of all, this service is easy to set up and use. A graphical interface was developed to allow for conversation configuration and training through a browser. Now let's take a look at how an application can be built using the service. As mentioned before, the application can use existing interfaces that interact with the user, such as Slack, Facebook Messenger, SMS messages through Twilio, desktop or mobile applications, chatbots, and even voice-enabled IoT devices. Once a message is received by the interface, it is sent to the application. Once in an application, we send the user's request to the conversation service where Watson determines what it is a user wants done. From there, multiple things can happen. We can pull in other Watson services as needed, or we can send the request off to the backend system to retrieve information to return back to the user. Now let's examine some of the components to see how the service works. There are four major components in the conversation service. First, the workspace is the collection of all related intents, entities, and dialogues. You can have multiple workspaces per instance of the service. For example, you could have a workspace for a voice-enabled car application, a workspace for home automation, and a workspace for a personal assistant, all in the same instance of the service. Then there are intents, which represent the purpose of user input. Next are entities, which are terms or objects that relate to an intent. And lastly, there is the dialogue to tie it all together. As mentioned before, an intent is the goal that users express in their input. Basically, what is it that the user wants to accomplish? The first step in using the service is identifying possible intents that a user would ask. In order to populate the list of intents in a workspace, it is important to step back and think of what users would actually ask and how they would ask it. There are multiple ways that a customer could ask to order something. For example, next time you're at a fast food restaurant, listen to how people in line order their food. You might hear things like, "Can I get a number one? I'd like to order number one, and I'll have a number one." All of these examples involve ordering a number one, but they are all worded differently. So with enough training, Watson can identify intents even with differences in how requests are spoken, but it first requires examples to learn from. For the fast food example, you would need to create the intent to order and list various ways that customers could place orders as examples to learn from. Watson would then be able to identify an intent in a request that it has never seen before. Identifying these intents is important because this allows Watson to direct incoming conversation requests to where they need to go. So here are some examples of intents. In a voice-enabled car, one would say, "Turn on the AC" to activate the air conditioner. In this case, "turn on" would be the intent because the user intends to turn something on. AC could easily be replaced with radio, heater, or wipers. The next example is more relevant to an online ordering system. If a user is having difficulty with the ordering system, they could say, "Help me complete this form," and get the assistance they need from an intelligent conversation bot. In this example, help is the intent because the user would like help in completing a form. Another example for an ordering system would be if the user wants to place an order. All they would have to do is say, "I'd like to order some paper." The intent identified here is to order. These are just simple examples of user inputs, but you can build out specific intents to handle the more complicated situations as needed. So now on to entities. An entity represents a term or object that provides context to an intent. Basically, if the intents are the verbs of sentences, think of entities as the nouns. So another way to look at it is that entities are the focus of what users are requesting. Bringing back the fast food example from earlier, the entity of the statement, "Can I order number one?" is the food order, in this case, a number one. Just like with intents, Watson needs to be trained to recognize entities. Entities, however, require a different data set for training. When declaring entities, a user first creates a class that represents multiple objects. Going back to the voice-enabled car example, we could expect requests that deal with turning on or off various functions in a car, such as the radio, AC, heating, wipers, etc. To cover all appliances in the car that might be turned on or off, the entity of appliance is created. Under the appliance entity, the user would list the different kinds of appliances that could be turned on and off, as I mentioned before, such as the radio, AC, and headlights. After declaring the appliance entity and the different kinds of appliances, synonyms of these appliances need to be given. These synonyms are words that users might use in conversation to refer to those specific appliances. For example, if we were talking about turning on the AC, we could use words like cooling, air conditioner, air, etc. The more values and synonyms that you add, the more likely that your bot will be to respond accurately. Now onto the dialogue portion of the service to tie it all together. The dialogue portion of the service is used to create a branching dialogue tree that represents the flow of conversation that might take place between users and application. This dialogue flow uses identified intents and entities to formulate a correct response to the user's request or to trigger specific actions. This basically guides Watson to respond appropriately when given an input. In dialogue, a flow is made up of different elements known as nodes. First are the base nodes. These nodes are starting points for incoming dialogue input. They are called when a certain condition involving an intent or entity is met. Next are the child nodes. These are nodes that are used when more input is needed from a previous node before a response can be made. Lastly, after a dialogue path has been chosen, a proper response is sent back to the user. Looking at this chart here, we can go through the example of a user saying, "Turn off the radio." First, the input is evaluated through each base node to see what intent is identified. So first, we go through the welcome node. This node is only called at the very beginning of the conversation, so it skips this and goes on to turn on. There is no turn on intent in the phrase "turn off the radio," so it skips over to the next node. The next node is the turn off node. Here, the turn off intent is identified, so we move on to the child nodes after that. The true node will be evaluated if there is no entity identified along with the turn off intent. For example, if you were to just say turn off without specifying an appliance, then this path would be chosen and the response would be, "I'm not sure what it is you want me to turn off," basically. The next child node is if any appliance is identified, in this case radio. If that's identified as true, then the response given is turning off the radio, and then something happens behind that to physically turn off the radio. The conversation service by itself can understand incoming speech and render an appropriate response, but it needs an attached application to interact with external data sources or to trigger IoT events. Another cool capability of Watson Conversation is its ability to return variables within the conversation response to trigger events in an application. These variables, we will refer to them as context variables. The application would need to be actively looking for these context variables or flags in the conversation response and trigger a function when a context variable is found. For example, if somebody wants to turn on a light, our application will look for a variable like light equals true, in the response object from the conversation. If that variable isn't found, then nothing happens. Once the conversation service recognizes a turn on light intent, then it would add light true to the response object within the dialog node. Our application would then find this variable and call the function to turn on the light. Another option is to connect the chatbot to an external data source. This would allow the bot to have answers to questions about particular datasets. In our second lab, we will use the conversation service with the Watson Discovery service to return relevant information about the hotel review dataset. So some possible uses for the conversation service include an automated and intelligent conversation agent that can respond to a customer's queries as a human would, but more accurately and in less time. It would even be possible to control a car using natural language, as we've been showing throughout this presentation. In combination with other Watson services, a bot can be trained on a large dataset and handle questions that are asked in various ways.